workshop is like it's gutsy. I believe it, but it's from simple chatbots to complex agents with Azure AI services. So I will try to give you an idea of how we can build complex agents that they do way more stuff than simple chatbots utilizing Azure. And I'm saying simple chatbots because when this all started 2 years ago with ChatGPT 3.5, the immediate use and what we've seen a lot was around, simple case scenarios like chatting with data, which is basically this type of scenario. You have some data, you put it somewhere, it's maybe FAQ documents, some information documents, and then you can do an interaction with those basically query, and you have your, let's say, ChatGPT of your own company come back with the details. Here we're querying a fictional company that has hotels, and we're asking, which hotels on a specific island have electric vehicle chargers that the customers can use, and then the chatbot, by utilizing the information that we have filled them in documents, then it can come back. This is more or less the simple scenarios that we've seen a lot in the past 1.5 years. Along with context summarization, with FAQ creation. That's a little bit, the first thing that made sense, to use the large language models. But in order to really, go a step beyond and really capitalize on the promise of the LLMs, because the promise of the LLMs is actually to provide a natural user interface, an interface for the user will be more natural than using the keyboard and the mouse and clicking things and writing things. Like, even in the near future with the voice, to actually do stuff with computers that they weren't be able to do before in this way. So let me give you what this scenario would look like for this fictional company that has hotels. Okay, so I will go to the Copilot chat, which is basically a maintenance Copilot. So imagine this company has multiple hotels around in several locations, and they have a central database where they gather reports from their customers or the personnel that something went wrong with some element in the room. The shower, the air conditioning doesn't work, things like that. And they wanna do that easily for the people that they want to create a maintenance request. So let me give you an example. So I will go and ask here the chat Copilot. I will tell them, can you help me create a maintenance request? And immediately the Copilot here will come back to me with the necessary information that it needs to create the maintenance request, which is actually the name or ID of the hotel, the room number of the hotel that have the problem, detailed description, and the location of the room. It's a bathroom, living area, and things like that. That's descriptive. So you see here that the Copilot asks me the necessary information by its own. I don't know what they need, but it asks me for this information. And then I say something like, the customer, they mentioned that they are on the ocean view. I don't remember exactly, the hotel, or the customer doesn't know exactly the full name of the hotel. Can you provide, and I ask the Copilot, can you provide me the exact name of the hotel? And then when I do that, the Copilot will figure out how to do that, and we'll show how all this happening on the background, and we'll find the actual official name of the hotel, and we'll say that, okay, this is the Ocean View Hotel located in Aruba. Okay, and you will see that then it follows up with what additional information it needs to create the maintenance request. But now the hotel name is not one of the information that it wants, because it knows that this is the hotel, unless I instruct otherwise. So, and then I will say something like, okay, so the customer told me, they mentioned that they're in the penthouse room. Let's make something else. There's a room, let's make 222, and that the tower doesn't have cold water. Okay, so I will click that, and from that, now the Copilot has all the necessary information to actually create the maintenance request. So it has the hotel name, it has the room number, it has the issue, and it has the location. It's in the bathroom. And then it will ask me, would you like me to save this maintenance request to the database? I will ask something like, sorry, wrong thing. I would say something like, yes, please, being polite always to the machines. And then I will reply that. And the maintenance request has been sent to the database, the hotel maintenance has been utilized, and they will address the issue as soon as possible. That's a natural interface that provides me actual useful information of what I need to do. It asks me, I provide the information, and in the background, it generates the necessary information. Let me see. I had an issue with one of the components, but let me see if this landed. Show requests about our melon functioning. I can do a search then. Let's see, we put room 2222 there, and here it is. That's the request that we just said a minute ago, okay? And now it's in the database, which then again, I can query the database and see what kind of maintenance requests are available there in order, for the technician to go and assign the tickets, to go for the technician to go. And let's see a little bit how this is done. So before going into the code, well, I'll show a piece of code, pieces of code. Let's go a little bit into the architecture. Okay, that's the original simple Gen AI chatbot, as we discussed about. You have a storage account. You put there, various documents like a list of the resorts of the hotels, an FAQ document, and then you utilize something that it's called in Azure AI Search. Azure AI Search is a vector database. We'll talk about it a little bit. What is it? And then you also utilize Azure OpenAI, and then you have the web application that you do the interaction, and that's it. A simple thing. What's a vector database? Basically, we convert the texts that they're there in vectors. That's if you remember your mathematical background from high school or university, that's a long string of numbers. And then we use these strings of numbers to find similarities between words. And that means it's different than keyword search, because keyword search looks for a specific, for a specific word in our search in the documents that we have. The vector search, what it does, it looks, of course, you can do exact same word, but also words that are very closely related. So you can find the results that are not 100% accurate descript with the same keywords that you're thinking. So we go from there, and then we go to the complex agent architecture. And what is a complex agent architecture? This is it. This is what we do. So we have a SQL DB where we put there all the information about our hotels. This is structured data, as we say. We have our hotels, our hotels numbers, the structure in tables, in columns. We have a Cosmos DB, which is basically a NoSQL database where we put their unstructured data, like JSON files, where you have different fields each time that are present or suitable for manipulating these kind of things. You have, of course, Azure OpenAI. You have a function app that works with Cosmos DB to vectorize, to create the vectors for each document that you put there, so we can search it with vector sets afterwards. And then, of course, we have a very important thing that's called here the semantic kernel. Semantic kernel, before I tell you what to do, is an open source framework SDK developed by Microsoft, available to everyone to utilize. It's a programmatic approach to work with LLMs. And what semantic kernel gives us is this orchestration layer between functions that we want our LLM to orchestrate to execute, and the user, to match the request of the user with specific functions like SQL queries and search and vector search and things like that, and saving to databases that we want to be part of the experience. And we need semantic kernel to do these kind of things. Of course, complex agent architectures in Microsoft can be extended with other features like API management. We can give you load balancing. You can use multiple LLMs. We won't go into this today, and also provide you the ability of creating policies for now managing your tokens, managing your costs, let's say, and your token ratios, and the performance of your model. But we won't go into this today. So let's go a little bit deeper into what semantic kernel is, and then we'll jump into code. Okay, so as I told you, is an SDK and framework that we utilize inside our code. And basically, you have two very important types of components that you use in the kernel. One is services, and services is simple. Okay, it's the AI services. Let's think about it like that. Okay, we want to do AI, chat completion, as we call it, basically the chat completion back and forth, or we want to do create embeddings. That means take some text and calculate their vector, the vector values. That's the endpoints. Okay, that's the one thing that you have in semantic kernel. The other thing is the plugins. And the plugins is where the things that you want to happen. The plugins consist of functions that you want to be available to the semantic kernel, and then to have it those also available to your LLM to understand what exactly the user wants to do. We have enterprise components inside the semantic kernel, filters, so you can do filtering of the prompts, or even to filter some of the prompts from the user before reaching the LLM, or filtering the LLM responses back to the user. And we have observability. If we have time, we're going to see that basically to see what's going on in your semantic kernel or in your application. And so in the center of this of semantic kernel is the function calling. And what happens, this is the magic, this is the nice thing, the orchestration that happens behind the scenes. Okay, so here's the person makes a request. Okay, so, and then the semantic kernel serializes the functions, and then it messages the model with the request of the user. With that, it sends a lot of other information that are basically, the function description to the LLM as part of the prompt. So the LLM is aware of what functions are available inside the semantic kernel and that they basically can use. Then the model processes the input, and then it has two roles. It either needs extra information that it needs to actually be able to decide what kind of function to use, and then it comes back to the user with asking with more details. As you remember, when I asked it, can you help me create a maintenance request? It came back and said, yes, I need this kind of details to create a maintenance request. So that's one road. Then this is the, this is the first case. Then it goes back to the user. The user says what it wants, and then it creates a loop, or it has the result and then gives the result back to the user. That's the orchestration that happens inside the semantic kernel. And that's a very important thing that allows us and will allow you to go out and build complex applications that can do a lot of great stuff. So, and what are plugins? Very quickly, I'm not going to go deep into that. Think of plugins as collections of functions. Okay, you have multiple functions that you put them under one umbrella that is called plugin, and you make the plugin available to the semantic kernel. Okay, as an add-on, let's say, to the semantic kernel. I won't go into details there. You can go and ask or see whatever you like, up in the internet. But let me go back now a little bit on the code side, okay, and see what is happening behind the scenes. So give me a second. Okay, let me go back here to my VS Code here, and I will show you some cases here. So let me put that a little bit down. Okay, this is the application that you were seeing. This is the code, the backend code of the applications. Okay, we have these database services files that basically has here, as you can see, functions. For example, this one that executes SQL queries against the SQL database that we have stored various information about the hotels in our SQL database, and executes and gets the results back. And then what's really important here, and we have, as you can see here, we have multiple, there are collections of functions. We have a function that gets all the hotels. We have a function that gets, for example, all the bookings for a single hotel. So multiple functions here. So what's important here is once we create this function collection, and we can create, before using semantic kernel, if we want to use it with the semantic kernel, we need to go and do what we need to annotate these functions for for the semantic kernel to be able to recognize them and understand what they're doing. So basically, you will see that on top of its function, we have these two parameters here that it provides the annotation for the semantic kernel to understand that this function is part of the functions that are available to the semantic kernel, can be available to the LLM to interact with the user. So you will see that this is valid for all the functions that we have here. And basically, the function that but I will go on that later. So one thing is that this is the file that we have the connection. Okay, so the name of the hotel. So let's go to the next interesting file that shows us other kind of files. Then we have the functionality that our chatbot could be able to create a maintenance request first, to ask for to create the file with the maintenance request, and this is basically the function that it does that. It's called not very easily to understand. It's called create maintenance request, and you have another function in this file which is basically save the maintenance request. First you create it and then you save it to the database. Okay, so two functions. As you can see also here, again, those two functions and their descriptions, which is very important for the semantic kernel to understand and the LLM to understand, for the LLM to understand what exactly they're doing. It's very important. You see here that they're annotated with semantic kernel tags. Another important thing is the parameters. Basically, the LLM, with help of the semantic kernel, understands what information to use by the function parameters. And the function parameters, and basically the ones that the chatbot asks us, is here. It asks us for the hotel. Oh, sorry. It asks us for the hotel. It asks us for the string details, for room number, for the details, for room number, and things like that. It's also important to have a good description. Let me put this out of the way here. Okay, maybe better here. It's also a good practice if the names of the parameters are not very well descriptive, to create descriptions for your parameters here. That will help the LLM to understand what exactly is required to ask in a request that it processes. Okay. And now we want to see how our program calls these things. Remember that we said that we have two things that we need to define inside the semantic kernel. One is services, and the other is the plugins. And this is defined in our program CS file. Let's see first the where we define. Sorry, it's somewhere here. Okay, where we define the semantic kernel service, and basically it's here. This is where we define our semantic kernel service, which service the semantic kernel will connect with. And you see the Azure OpenAI chat completion. We have the details. We need, of course, the details of the deployment name, the endpoint, and the Azure OpenAI key. And then a little bit down here, we see that we declare the plugins that are available to the semantic kernel. You see that we have a matching between the names of the files that were here, database service and maintenance request plugin. That's basically will tell the semantic kernel what kind of functions are available and should use when communicating with the LLM. Okay, good. So what else is sent? We need a little bit more because LLMs are sometimes weird things. We wanted to give them some instructions. So we have another file here which describes the instructions, what we call the system prompt. Okay, that what's the function of the copilot? This is basically the system prompt that it sends back and forth in every request. Your friendly assistant, blah blah blah. Ask the information, and if the user confirms the details that you have given them, ask them if you should save the request to the database. If you're always ask for a confirmation. Okay, basically like that. Okay. What else? Okay. And now let's close the circle with the vector search. Okay. Let me go a little bit and see a little bit of Azure stuff here before going back to code. Okay, there's enough time. So it's the Azure OpenAI services. You will see what kind of deployments we have available here. That's our LLM model, GPT-4o, okay? And that's our text embedding model. This is the model that actually creates vector embeddings from the text that we give them, okay? So let's go and see something else. Let's see our Cosmos DB. This is our Cosmos DB. We have enabled vector search for NoSQL API in our Cosmos DB. That means that it's able to calculate distances between vectors. Okay, you need to enable that. It's still in preview. Pretty soon it's going to be in GA. That Cosmos DB is a vector can be in vector database. And then here in the Data Explorer, we can actually see the containers and things like that and what is saved inside our database. Let me go and show you not one item. I think we have the time. Okay, and I will show you what we saved. That was our last, you see the room 222. And here is the request vector. Here you will see what we mean by vectorizing the text. The text that you see here is actually represented in the vector space as with this number. But actually 1,526 or 34, if I'm not mistaken. That's the dimensions that the specific model, the dimensions of the vector space that it calculates, okay, based on some deep grammatical model that it has inherited. So that's basically where the maintenance requests are set are saved. And to vectorize these things, I told you we have an Azure function. We have a function in Azure. We publish it as an Azure function. Let me a little bit show this. It's a function that we create here in C#, and then we publish it in Azure, and it then watches the specific database and the specific container for new items, and it vectorizes the new items. Okay, what would be the most important here to see? Basically that we're using an embedding deployment model for this, basically to create that it only picks up documents that are not vectorized, and it does that, and then it's actually vectorizing the document and save it into the database. Okay, let's put it all together, okay, and let's connect a little bit the functionality what I've shown. Okay, let's go a little bit back. So I'm going back here. Okay, so remember, we were here in the Copilot chat, and we said, can you help me with a maintenance request? When we said that, immediately, semantic kernel communicated with the LLM and passed, basically, the parameters along with the system prompt and other instructions. It passed those parameters to the LLM, and then the LLM understood that we were looking for this, and it came back and asked us for these four parameters. Then we said the customer mentioned that they were at the Ocean View. Can you provide the exact name of the hotel? When we did that, then the LLM understood that it had to use something else. And then it communicated with the semantic kernel. And based on the annotations here, it understood that it had to run this specific SQL query, which was executed against the SQL database and actually returned back all the hotel names from the to the LLM, and the LLM could do a matching there and understand which hotel name we were referring to, and it came back to our hotel name here, the Ocean View. Okay, and then we said that customer that they're in the penthouse suite, room 23 on the south doesn't have a hot water. Again, the maintenance request matched each of the information that we have here to the specific things that we want here, and then it came back to us with the details of the maintenance request and asking us for a detail. And then when we said, yes, please, it went back and basically executed the save maintenance request. So it executed this piece of code to save the request inside the Cosmos DB. And summarizing. This is the way, and one more thing, since we have 2 minutes. So since we talked about observability, so we can utilize application insights in Azure, which you can actually is a login monitoring, a functionality available in Azure for monitoring, logging, monitoring basically web applications. There might be web apps or web APIs. And we just put this code here in the program CS. Let me show you the code. It's pretty easy to put it here. It's basically this kind of code here. Just put this kind of code here in our program CS, and we connect our web application logging with application insights, and all the telemetry ends up there. And let me go and show you a little bit how that does it look. I think it's quite interesting. Let's go here. Let's see the data that comes here, and we will find the request that we did. Different kinds of requests here. Let's find one. Okay. Let me do a refresh. Let me select only. Dependencies. Okay, that should be the last one that we did. No. Let's do somewhere here. Let's see this one. So here we can see basically the process of what this request was doing. It was a call to the chat completions GPT. You can see the prompts that were there. Okay, and you can see that every time that the semantic kernel connected, talked with the LLM, it provided all the history of the conversation that we have. You see here, can you have a maintenance request, the response of the LLM, and then additional information. Every information that is back and forth, you can see it here, so you can understand how the conversation is constructed, what kind of data it goes to the LLM. And also there's another, let me see here, I think it's here. There's another very nice feature where it can show you a very nice diagram that you can understand what's going on. Okay, so here is our operation start, chat completion GPT, that it goes there, and then the different operations and what exactly is executed in your code. And with that, I think I'm 1 minute over my time, so I will stop here. That's it.